All right, I'm a program manager at IARPA. If you don't know IARPA, you might know DARPA, the Defense Advanced Research Project Agency, which brought us such things as the internet and GPS and good stuff. So IARPA is the same story except for the intelligence community. We haven't invented the internet yet. We've been around for only 10 years, but we're working on it. We've done good things in quantum computing, forecasting, different geopolitical events, and of course we do stuff in AI, which is what I'm going to be talking to you about. So I'm a program manager. I run research programs in AI. I also help lead a interagency group of R&D coordination. Mike Garris actually mentioned it earlier today. We had a strategic plan for all of US government that came out a few months ago. It's a revision of the 2016 plan. And we've got other documents that are coming out shortly. So that's enough preface. Let's get to the good stuff. So let's say you're making an image classifier, a thing that probably many of you have actually done. And so you feed into that AI some input. So here we've got a picture of a banana, right? And we say, what does the AI think it's seeing? And so we've got bar charts, different confidence levels for different object types. And so we see that the AI is very confident it's looking at a banana. Great. So the problem is, if you got some bad guy, some black hat bad actor, they can put a sticker onto that table. They've gone and created a special sticker, and they put it into the image. And now the AI changes its mind and is very confident that it's looking at a toaster because of the existence of this sticker in the image. So the point of the story here is that, like humans, AIs are subject to camouflage, illusions, cognitive biases, etc. But because AIs are not humans, the sorts of problems that it is susceptible to are different from the ones that we are susceptible to. So it may or may not be fooled by the same sort of camouflage that fools us, but there are whole other categories of things that fool them. And unfortunately, existing AI techniques, and by this I really mean deep neural networks, are full of these things. They're called adversarial examples, which adversaries can find and exploit. And so to show you just how deep this rabbit hole goes, this is a picture, several pictures from different angles of a 3D printed turtle. And if you go to a machine learning conference, you can probably see the people who created this. I've held this in my hands. All right, you can look at it from multiple angles. And the box around the image indicates what the AI is thinking that it's seeing when it looks at this image. So those that are in green were classified as a turtle. Those that were in red were classified as a rifle. And those that are black are classified as something else. In case you are colorblind, there are no green up there. The AI was very confident from almost every viewing angle that it was looking at a rifle, not a turtle. And the reason for this is because there's some patterning on the turtle that the AI is attending to. Now, clearly, the researchers could have done the reverse, which is that they took a rifle and put some subtle patterning on it that a human wouldn't notice, and then the AI would say, that's not a rifle, that's a turtle. Now, these were machine learning grad students, and they wanted to be able to get back on a plane in order to go back home after the conference, so they didn't do that. But you can start to imagine all the sorts of situations where an ability to fool an AI like this starts to get really material, particularly if you're in a security context. So this is by far the most famous form of AI security concerns. Adversarial examples is the name that I mentioned for them on the previous slide. Let's go to another problem. So let's say you're making a self-driving car, possibly of interest to some of you, definitely interest to a lot of consumers, such as myself. I would love to have a good self-driving car. In order to make that, you need to feed into the AI that's doing computer vision on what it's seeing as the car drives around. You want it to get traffic signs down so it knows what to do on the road. So you give to that AI during training a bunch of pairs like this, a picture of a stop sign and then a label that says this is a stop sign. Great, so the AI will learn from that and learn that red octagonal things with STOP on it are a stop sign. But if we got our black hat bad actor in here again, and they can get into just a portion of the data and do this, where they change a little bit of the data and change the label. Here they've put in a yellow square into the data. The AI is going to do exactly what it's supposed to do. It's going to learn from the data that it was given, and it's going to learn, okay, red octagonal things with STOP and a yellow square on it, that is a speed limit sign. So now you put that in your self-driving car, and your adversary can go put a Post-it note on a stop sign, and the AI will be very confident, that's not a stop sign, I know what that is, that's a speed limit sign. I'm going to go right through this intersection and hit the pedestrian, say. So adversaries can insert what we call Trojans, also called backdoors, into AIs through small manipulations to training data. There's also other ways to do it, by doing surgery directly on the neural network. That's harder. This is the easier thing to do, of poisoning the training data. And if you're sophisticated and you're doing transfer learning off of things, so you say, well, in order to train up my image classifier, I'm going to go pull some big, ornate neural network that Google or someone made. I'm going to pull that off of GitHub, and then I'm going to just fine-tune it to my use case. Importantly, any backdoors or Trojans that were inserted beforehand can potentially transfer over as you do transfer learning to your new domain. So if you're sophisticated here and doing things that can really help out your sort of computational overhead and the resources you need to bring to bear, you can be even more vulnerable because your whole supply chain isn't really under your control. So that's another problem. Let's go to a third one, completely different. Let's say you're making a face identifier. No issues there, right? So you take photos that look like this. You got this guy, and you say, that's John Smith. And you feed that data into your AI so that it can learn what different faces are with different names. Great. Now you got your black hat bad actor there. They get the AI. And they're going to bang on that AI and say, show me who John Smith is. And the AI will reveal this. So this is real data from a real use case where the bad actor had access to the AI, and by essentially interrogating that AI, was able to extract or invert out data that the AI was trained on. So adversaries can invert AI models to learn about the training data. And this can work even if you have black box access to the AI, so you don't have understanding of the parameters inside. So if you have PII, confidential data, proprietary data, whatever that has gone into your AI, that AI itself encodes that, and it's possible to make inferences about that data, to include very precise information or pretty coarse-grained information, which still, in this sort of situation, is enough to be worried about. So what's the overall story that I'm trying to convey to you? AI is not secure at all, and this is a problem. So AI is not secure. And sort of the way to think about this is just as in the 70s and 80s when software was spreading without much thought for cybersecurity, today AI is spreading without a lot of thought for AI security, or what we call AISec. And what this means is that just as in the past, government and private sector systems are vulnerable to both sophisticated actors and pretty unsophisticated actors. A lot of these attacks are things that just someone with a single semester of a computer science degree can pull off of GitHub and get things working pretty readily. And this is bad, of course, but it's going to get worse as AI grows and continues to be more and more a part of our systems. If you don't have AI in your systems, it's not a problem. It's not a thing you need to be concerned about. Just as if you aren't using any IT, you don't have to be worried about cybersecurity. But if you aspire to use these things, then this becomes a new attack surface for you. And so I'm concerned about attacks on US government capabilities. Obviously, in the context of national security where I work, any attack on kinetic capabilities is particularly concerning, because if you have a misfire, then that could be a disaster. Critical infrastructure, private sector, and really the private sector written more broadly to include just any place where you could do large amounts of economic damage, either because you're a state-level adversary or just because you're a griefer who wants to get some lulz. So how can we think about this set of problems? So in case somehow you got into this conference without knowing, this is the general process by which you create an AI. You use training data to train an AI. Then at runtime, you give it new data, which we call inference data, and the AI takes some action, like gives an output of what it thinks the image is. And so AI security can be thought of in terms of where the adversary is getting in. So in the first thing that I showed you, the bad guy is coming in over here on the left by manipulating the inference data. And we call this making the AI do the wrong thing, or adversarial examples. But then I also showed you bad actor coming in at the training data. And this is to get the AI to learn the wrong thing, putting in Trojans. But then you can also have the prospect of the bad actor getting the AI itself and making the AI reveal the wrong thing, what we call model inversion. That's the technical name for it, and there are multiple kinds of reveal the wrong thing in there. So this is sort of the space of AI security as we currently understand it, and you can see there are these multiple problems that hit at different points in the AI training and use pipeline. So my goals are to fix all those problems. So at IARPA, we're running research programs to address some of these issues. DARPA is also running some programs. NSF has some great research in this space, and the private sector has also been doing some great things, but none of them are solved. So what would solved mean? Our objectives for do the wrong thing are to, one, ideally remove adversarial examples, make it so that there is no camouflage that will fool this AI. I think in the limit that this is not strictly possible because the AI will get as good as humans and we are susceptible to things. But barring their removal, we could instead just try to prevent the discovery of adversarial examples. Even if a camouflage exists, if there's no way to actually interrogate the AI in order to figure out what the right camo pattern is, then it's statistically unlikely you'll ever find it. So that's the objective for do the wrong thing. For learn the wrong thing, my objective is that if a bad guy put a Trojan in an AI, we will be able to discover it. The objective is not to prevent the Trojan going in, just because with current machine learning methods, the supply chain leading into your AI is long and vast and diffuse and includes many different actors. It's just infeasible to try to protect every element of both the data sets, but the software stack and the hardware stack and so on and so forth. I just want at the end of that pipeline to verify the thing that came out. So you can think of this as a virus detector paradigm, right? You don't vet everything that went into the software, you just vet the software once it's done. And then for reveal the wrong thing, we want to prevent bad actors from being able to interrogate an AI to learn this stuff. And there's a certain sort of wrappers you might want to put around the AI. More likely, there are things inside the AI as it's learning that you essentially put in regularizers or techniques to get it to not accidentally memorize the data. But all of these are areas of active research. So you may have realized as you're thinking about some of these problems, some techniques that you could use. And unfortunately, there's a sad fact that they point in different directions. So for example, if you're detecting Trojans, or trying to be a bad guy and create adversarial examples, or invert an AI in order to get the data out of this. So this is a mixture of good things and bad things. They all tried to read the AI's models in some way. Try to read what the AI's sort of internal concepts are. So to detect Trojans, we want the AI to be legible. But if we want to prevent model inversion or adversarial example creation, then we want the AI to be illegible. We don't want you to be able to read it and know what's going on. So these point in different directions. Now we can imagine a possible future ConOps, concept of operations, where we make a legible AI and then we inspect it to make sure that there are no Trojans or backdoors. And of course, we could be inspecting it for many other concerns that aren't sort of security based, like bias and so on. And then, before we deploy it, we convert it into some illegible format so that once it's out in the wild, bad actors can't bang on it and either reveal the data that it was used, that it was developed with, or figure out camouflage that works against it. Now, this is the pipeline that I presented to you in all the different places where AI security concerns show up. My big concern is that this isn't the full story, and that there's some other attack out there that we're not even aware of right now. Because each of these attacks, there was a moment in which no one was really thinking about it. Maybe if you got a really paranoid cybersecurity person, they would bring it up conceptually, but it wasn't clear how it would actually work in practice. But what we're seeing is that just as we have hardware vulnerabilities and software vulnerabilities, we have this whole new world of algorithmic vulnerabilities, where even if the hardware and the software are doing exactly what they were supposed to, the algorithms themselves have vulnerabilities. And this is just a young field, and so we don't actually know what all the different problems can be. So while this state of affairs has been sort of stable for the past, I want to say 3 years or so, I have no bets that it's going to continue to be stable. So the point of this story is that we need AI security. We need AI sec. And US government and others are doing a lot to improve our state of knowledge and the techniques that are available to anyone trying to improve the security of their systems. And there are great things that are now on the shelf, on GitHub or GitLab or somewhere else, that you really can pull down and secure certain aspects of your pipeline. And for those of you who are interested, I can talk about those later. But we don't have the whole thing solved at all. I'm optimistic that some of these problems are going to get solved very soon because they overlap with just conventional concerns of does my AI work good, right? But some are very specific security concerns that we really need targeted effort on. So we need AI sec, and we're working on it as a government and as a society. So thank you. Take any questions. I may have done a perfect job, so I've addressed everything. So no questions in the audience, which is fine. One up front here. I don't know if there are mics running, so you can just speak up.
Isn't AI security primarily at least for data validation, primarily a private sector thing?
No, I mean, it's anybody who cares about their data, right? Who cares about whether or not their data is public. So I'm sorry, the question is data validation, data protection primarily a private sector thing? And I don't think so. In fact, I think all of these security concerns that I just showed straddle both private sector and public sector. The only part that really varies is, does your adversary care, right? And do you care about some bad actors screwing up your stuff, right? Because if you're managing advertising click streams, there's sort of a cap on how much someone can screw you up, right? There's a cap on how far out of the system's normal behavior that it can potentially be kicked, and that will do a certain amount of dollar amount to your company, right? But if you're operating in a situation where one screw up can cost a life, right, you might want to have that nailed down. Or if you have a situation where your adversary has a lot of incentive to screw you up, even a little bit, now you can be pretty sure that someone's going to be getting in there, and so you want to patch these holes. Unfortunately, AI security is not like AI robustness in general, where things might be statistically okay. If we're talking about robustness, 99.999% of the time the thing works, so that's good, we're set. Even if you have the system working 99.99% of the time, if you have a human that's actively trying to screw it up, they're going to go look for that 0.001%, and they're going to find it and leverage it, right? So if you have those sorts of people that are in your ecosystem, then this gives you a lot more incentive to try to patch the holes. But if you don't care, and they don't care, then you're safe. Hopefully you're all working on things that matter, so these could be things that are relevant to you. Other questions? They're in the middle. I don't think any mic's going to get to you. So.
Okay, I'm Joe from Connecticut, and the question is, this is interesting. You're talking about AI security and the challenges with vision, AI, and great. Can you share some of the other fundamental use cases in the area of machine learning and AI that you guys are interested in?
You mean at IARPA specifically? So I run a program that's about computer vision. So you want to be able to watch videos that are hours and hours long and identify if some activity of interest is happening there. So a lot of the work that's been happening in computer vision over the past several years has been about object detection, right? Recognize that was a banana that I showed you, right? Objects are great, but sometimes the object isn't the thing you're interested in, it's the activity that the object is doing. So you don't care that there's a person there, you care that there are two people fighting, and you want to know that that's happening compared to two people dancing, which looks very similar as far as AI is concerned, right? So we're trying to develop techniques in order to do activity detection very well. That's just one area that I run. Basically, I don't want to say literally everything, but I think the majority of the research that IARPA works in, machine learning techniques writ large have entered into our toolkit in one way or another. It's really exciting. Sorry, and you have a follow-up question?
Follow on. What about in the area of prediction and like handling data and making inferences about the data, identifying outliers? Is that stuff that you guys have pretty well figured out, or is there areas there?
No. So the issue of data management and outlier handling is a problem writ large, right? Generally at IARPA or DARPA, these parts of the government that have a mission partner that they work with, we need to ask ourselves the question of, does the private sector or some other part of the research ecosystem already have an incentive to work on this problem, right? And if they do, then that means great, we don't have to work on it, right? We want to address those market failures that affect our customers. And so the issue of how do you handle outliers is a thing that is being attended to in multiple parts of the research ecosystem, be that private sector or public sector. I think that outlier detection is a really well understood problem for certain domains and a really poorly understood problem for some other domains. So I suspect that there's going to continue to be advances there. But I don't think that we have, as far as I know, any research on that topic as an abstraction, as opposed to applying it to a particular domain. I think there was a question over here.
Thank you. My question's about the model inversion. So
Yes.
The example used was the image of John Smith being used to train the model, then inverted to show a picture of John Smith.
Yeah.
But if I had confidential information on 100 different companies and I wanted to classify them into 6 different categories, so it's no longer one-to-one, it's a group of them to a specific category, is there still a risk of someone getting identifiable information out of the model by inverting it?
So I don't know that I follow your precise situation, but I think I have an answer for the category of question that you're asking, which is that there are many kinds of information that you could want to protect, right? So at our most fundamental level, it's the precise data that went in. So we showed a face here, but that could have been a social security number or a credit card number, something like that, right? And so a credit card number, you need the number, the exact number, in order to really wreak havoc. Now, you might know statistical things about that credit card number, like, oh, there's a 90% chance the first number is a 3, and then the second number, it's a 30% chance it's a whatever, and that sort of thing you might be able to get at without knowing the exact number. But then once you have those statistics, you can just run through them, and it's like randomly guessing, except you are biased in the direction of the correct answer, right? So even these sort of coarse-grained facts can get you to precise information. But then also the coarse-grained information alone might be a problem, just in and of itself. So if you have a situation where you have proprietary company data and you know that you put these 3 companies that are all of a particular class together, and now we are able to invert from your AI, companies in that class have terrible profit margins, right? And they say they were privately traded firms, and so that wasn't public information. Now that could be a problem, right? And you can imagine in national security paradigms all sorts of situations where coarse-grained information is enough to be an operational concern. And so those are the sorts of things that we're concerned about. To be fair to the private sector, there's actually a fair amount of work on protecting the individual data points. So the term of art here is differential privacy. They want to have techniques to train a machine learning model so that when you look at the model, you cannot tell the difference between whether your data was used to train the model or not. So it's differential privacy, can't tell the difference between the model with or without your data. This research was actually funded by the Census Bureau, which has a constitutional mandate to be able to do that. They want to release as much data as they can, but they cannot release information that would allow your census data to be inferred. So they've been hung up on this for decades. And they've made some great advances. So differential privacy, unfortunately, is all about protecting that precise data, right? And I'm actually very optimistic that within a small number of years, that's going to be sort of a done deal, that we're going to be using deep neural networks in a differentially private way without a big computational cost. So that's good. But if you have coarse-grained information that you care about, almost no one's looking at it because that's rarely the sort of thing that you get sued for. Whereas leaking PII or credit card numbers or so on, or someone's DNA sequence, that's the sort of stuff that gets you sued. So there's still further stretches that we need to go in order to address this problem. In the middle there.
Hi, so I had a question about vulnerabilities in general. I know you talked a lot about vulnerabilities concerning specifically computer vision AI.
Yeah.
Are there any other vulnerabilities that would be particular to other forms of AI, such as language processing, big data crunching, etc.?
Yeah, so in principle, all of these can apply to other problem domains. I've shown computer vision because it's one of the easiest to represent on slides, and also one of the areas that deep neural networks have been advancing the most in. But you could apply this to audio, say. Now, it is not the case that all security concerns, you can do the math in the same domain, that's fine, but it might not mean the same thing. So for example, if I do model inversion and get someone's face, right? The average of a whole bunch of pictures of your face is your face, and you know what that is, right? So then that allows you to act. But if we had, say, a speaker ID system, and you had many different audio clips of your voice that Alexa or Google or whoever is building up, and we asked for the average of your voice, what even is that, right? So in my case, it'll be quotes from YouTube videos, but that is not necessarily a thing that's going to be able to help anyone trying to understand who is the person speaking. So you can see that just because the math will apply, the operational reality will not always be the case. But generally, all of these things can show up in other domains, and they definitely do. Up here, front? Sorry. Last question, I think.
Yeah, last
right.
question.
So, with multi-tenant
Mm-hmm. Yeah?
if I'm an adversary, all I have to do is get one of those ends. I don't need to worry about the other ends for it to be a security vulnerability. How do we protect against not understanding, what the adversaries are going to be using? I don't know if I'm articulating it.
Sure. So the question is, when your inputs are coming in from multiple domains, so your AI is reading in a bit of text, and it's looking at some video, and it's doing some audio, and it uses multiple things as inputs in order to make some assessment that gives some recommendation. The idea is that all of those are potential things that the adversary can hit. So you have many different kinds of inputs, many different sort of ports, essentially, that the AI, that the adversary can be going after. This is true, and you would think that this would, on balance, mean your system is more vulnerable, and it is in that there's more opportunities for the adversary to poke your system. But hopefully, if your AI is actually using information from multiple domains, it's going to be harder to fool it writ large. So as an example, if you are watching a video of this, say at home, if you're live streaming, so you've got audio and video on me walking around, right? And if something starts screwing up with the video, you're still going to be able to use the audio in order to make inferences about what's going on, right? So even if I wear camouflage, you will still understand that there is a person speaking here, right? And if the audio cut out, you would still be able to look at the video and see that there's a person speaking, right? So it depends upon how exactly you've set things up, but there is the opportunity for what we call defense in depth, where you have many different kinds of sensors that are running different sort of decision algorithms, and if you take, say, the ensemble of them, then you're doing well. As an example of this, just a few weeks ago, there was a paper that came out on Archive of some people who made an adversarial t-shirt. So it's a t-shirt designed to screw up person detectors, and so it's got some patterning on it so that if you've got some security camera or something looking for people, you won't be able to get seen. Great. And it works quite well against individual AIs. But if you have an ensemble of multiple AIs that are doing the detection, then it doesn't fool all of them, and so it starts to get alerted. So defense in depth is a great way to begin to address some of these problems, but you have to actually do it. Now, I'm very confident that was the last question because Kirsten's getting antsy over here. So thank you all. Thank you.
Thank you so much. All right, thank you. Moving on to the next session. We're mixing it up a little bit, so this one will be a panel format.
Wanda. Oh, I'm 5.
So I'll start as the panelists are getting seated. So on the far right, we have Josh Elliott, who is a director of artificial intelligence at Booz Allen Hamilton. Not to confuse you too much, but to his left is Josh Marcuse, who is the executive director of the Defense Innovation Board. In the middle, we have Pam Isom, who's the deputy CIO for Architecture, Engineering, Technology, and Innovation at the Department of Energy. To her left, we have Colonel Jason Brown, who's the director of the Chief of Staff of the Air Force Strategic Studies Group. To his left, we have Tom Beach, who is the Chief Data Strategist and Portfolio Manager, Office of the CIO at the USPTO. And then finally, to my right, and Tom Beach's left, we have Captain Mike Kanaan, who is the co-chair for AI at the Air Force Headquarters. So I will pass things over to Josh Elliott.
Thank you very much, Kirsten, and thanks everybody for joining us today, and thank you to the panelists. And Kirsten did the introduction, so we're going to jump right in. I'd like to start with you, Mr. Marcuse. This has been a big week for the Defense Innovation Board, and one of the more than one of the accomplishments that you had this year. Can you speak a little bit to this major milestone that you guys just achieved and the approval of the Ethics Principles Project?
Sure, I'd be happy to get into that. This happened last Thursday, so this is really hot off the presses, and it's fitting to talk about it in public really for the first time at a place where so many of the people that are the builders of the technology are here. But before I do, let me just clarify that I am not speaking for the Defense Innovation Board, and I'm certainly not speaking for the Department of Defense, but I'm happy to share my perspective. So what happened 15 months ago was the department announced the launch of the Joint AI Center. And on the day that they did that, they also launched an effort to define what should be the principles that guide the ethical deployment and ethical development of artificial intelligence for the U.S. military. But in asking that question, I think we all knew at that moment that there were implications not just for the United States, but for really the militaries of free and open societies around the world that are charged with defending their societies and our values using these technologies that raise important questions that have been talked about by Jeff and others just a moment ago. So we set out to build a robust, inclusive, and transparent process to really tour the country, talking to experts, not only people that are, Turing Award-winning developers, but also the critics of the department that have concerns about privacy, have concerns about arms control, have concerns about killer robots and things like that. And so we had this inclusive process to bring them all in, and then that process came to a conclusion last Thursday. And we ended up with 5 principles. And you can read the report. The report's 70 pages. It's actually very in-depth, and I encourage you to look at it at our website, which is innovation.defense.gov. But the 5 main principles, Josh, are that AI should be responsible, equitable, traceable, reliable, and governable. And I think the idea is that as the department figures out how to cross all of these technical chasms, and they think about operationalizing these, not only for warfare, but probably even more frequently just for modernizing the business processes of the department, to make sure they keep those principles in mind as they're building the tools and as they're applying them. And I think it's important we have this conversation now before there's been a major issue, because the department is an ethical organization. And this just figures out, how do we apply the 70-year heritage of being ethical about the deployment of all kinds of complex engineering systems for this new frontier of AI. And it's a really exciting time for the department.
Excellent. Thanks, Josh. This is actually a good segue over to you, Colonel Brown. I was wondering if you could talk a little bit about some of the accomplishments and even some of the challenges that exist in your time leading up the Humanitarian Assistance Disaster Relief National Mission Initiative, seeing as the JAIC was one of the first recommendations coming from the DIB. Can you speak to those?
Yeah, absolutely. There were a lot, and I read a book recently called "The Imagineers of War" by Sharon Weinberg, and talks about the history of DARPA. And there are so many parallels of how DARPA was started and all the challenges as it relates to creating an organization to ultimately, address the blind spots that exists within any institution, right? We all have blind spots as it relates to threats, as it relates to opportunities, and the JAIC was essentially constructed to make sure that we were taking advantage of the opportunity that was there as it relates to artificial intelligence. So as you can imagine, there was, there were senior leaders who were very, big sponsors of the JAIC, and they created this task organization that ultimately was needed to address the fact that the department had to do something to kind of flip the script as it relates to prioritizing development over sustainment, because for so many years we've been doing the reverse. And so the JAIC got money, the JAIC got resources, manpower, and that immediately, of course, creates some skeptics within the department until the JAIC can start providing value. So we started with several different national mission initiatives. I led and kickstarted the Humanitarian Assistance Disaster Relief initiative, which, HADR is a mission that the department does every hour of every day around the world. So it's a very big mission. We focused on our users first. So National Guard, Northcom, for example, domestically, because of the amount of disasters that we respond to domestically, and so we started with fire and floodline mapping, which is what they're continuing to work on. But it's really important to understand that it's not really about the projects, right? The projects are just a catalyst to essentially uncover a lot of different challenges as it relates to, people and education, as it relates to plumbing and all your IT infrastructure, if you will, as it relates to policies, procurement, lots and lots of challenges as it relates to procurement, and then also partnerships with academia, with private sector, with allies. And so these projects have been a vehicle for that and continue to be so.
I appreciate that. Just a quick follow-up question for you, Colonel. You just listed a lot of challenges. For those agencies or organizations that are just thinking about starting up an analog to the JAIC, is there one that you would start with?
People. Undoubtedly. Education, get people understanding the technology, get them into, so we talk about educating our folks from the flight line to the 4-star. And it really is putting as much emphasis at every single level of your organization to understand how you can take advantage, how you turn, so for especially our senior leaders have been taught, how do that data and software and IT infrastructure are things to be protected. We haven't taught them how to use those things to their competitive advantage. Mm-hmm. And so that's something we're focused on, not just cultivating digital talent within our ranks and coding and other things that we're trying to do that I'm sure Mike will talk a bunch about, but also educating leaders on how to employ this technology.
Excellent. So, we've heard a couple perspectives, and we've seen quite a bit of requirements and funding coming out of the defense and intelligence communities around artificial intelligence, and we're starting to see an uptick from a civilian perspective. And Pamela, I'm wondering if you could talk a little bit about some of the things that you're doing at the Department of Energy, and specifically the research going on in the labs and some of the challenges that you guys are experiencing and how you're overcoming them.
So I can start by sharing some of the things that we're doing. We have a lot going on in this area of the grid and resilience around the grid, and making sure that energy is supplied, power is supplied in the manner that we need it. And so you'll see and hear a lot about storage management and how we are working with renewables and making sure that energy is available, and that by default, some of the renewables meet the requirements of the needs of consumers. So in communities, for instance, you'll see and hear about batteries, and the batteries that support the renewables, and then those kick in if there is an issue with power supply, just by default. So those are some of the things that we're looking into, and I can only share those things that are already public. So if you've already heard about this, I apologize, but that's kind of the nature of the game. Another area that we're looking into is things around documents and data itself, but more around products and documents, and how do we go about categorizing these better and more efficiently, because there's a lot of manual work and research that goes into how do we categorize the material. So an example would be in the human resources area, and even in acquisitions. it would be really nice to be able to take listen in on a conversation, and based on that, have the SOWs automatically get generated. Instead of all the research that you have to do to go about and all the exchange of conversations to get a SOW or PWS generated, why not just use AI to generate these materials for us, and not only based on what's going on in the room, but based on the materials that also contribute to these types of outcomes. So we're looking into things like that. And then the national labs are just really busy around energy efficiency, but cyber. So we are looking at things to divert hackers. I want so much to frustrate the you-know-what out of these hackers, right? Frustrate them, make them wish they never looked our direction, right? And so I can very confidently say I know that there's work going on in that space. So those are just some examples. And so as far as opportunities and the research and funding opportunities, so watch the energy.gov website, but we announce things all the time in this area and in other areas, even like transportation, and how do we make transportation more efficient, and how do we make the vehicles more efficient, things like that. You'll see items like that all the time on the energy.gov website.
Excellent. Thank you for that. We'll stay in the civilian sector. Tom, you're in a unique position at the USPTO and dealing, perhaps with some of the AI intellectual property policies. I'm wondering if you could talk to us a little bit about what the PTO is doing and how you guys are approaching that.
Sure. Great question. I will start by saying I'm going to parse the two, which policy about whether or not a particular technology using AI is either patentable or AI that creates a trademark is a wholly different conversation. Won't really espouse on that too much other than we follow our statutory guidelines, whether it's living organisms, AI, or any other type of technology that is arriving now that has a complex policy element to it. But the implementation or the operationalization of AI at the USPTO is an interesting one. One, because we're a regulatory legal organization, so we have certain limits of which AI can actually produce. It can't decide whether something's patentable. It cannot decide the likelihood of confusion, which is what the element for trademarks is. So it's very challenging in some ways where we can apply it. But I think Colonel Brown, you mentioned it too, is we focus on the mission. So the mission is to timely deliver quality patents and trademarks. We get 600,000 patent applications a year. We issue 300,000. They average claims. If anyone's ever read a patent, at the end there's a claim, one sentence, 5 million of those a year. So there's a huge risk level of not correctly identifying what is patentable. So we use technology in different ways to augment and federate search, and that's the ability to find and locate documentation to be applied to the examination process. And one area that has been a really interesting use case that I think I'd like to share is one that has a very specific ROI, meaning we spend a lot of money on a manual process to classify documents. And what that means is by what technology does it belong to? Is it biomedical? Is it electrical? Is it a semiconductor? So we spend an inordinate amount of money on this, and we have just successfully launched an AI system that's close to beating our vendor on this. It's able to take in documents and give it the actual correct classification symbol. So part and parcel is that is the challenge. How do we validate this at the scale that I mentioned? So if we're getting 2,500 cases a day, we can't have a person validate 2,500 times every time the AI does something. So, that's one of the biggest challenges, I think, in this path forward is learning to trust. That's built on the data you get. And two, how do you let it go and actually let it function and keep it within the confines of your organization's structure and mission. So that's really for us been a tremendous opportunity to apply technology to our own business process. And I know, we talk about the US a lot, but it's certainly a competition internationally. I mean, other IP intellectual property offices around the world are fast and furious of both on filing of patent applications with artificial intelligence, but also leveraging it in multiple different ways. I think earlier the gentleman talked about image searching. That's something really relevant and near and dear to us. But again, any sort of error in there has a long-term issue, which is litigation. If the scope of intellectual property is not correctly identified, right, there's large implications at the other end in terms of litigation. So we have a high risk but a high reward in our endeavors on that.
Excellent. Thank you very much.
Sure.
So, Captain Kanaan, we've talked about policy, we've talked about ethics, we've talked about some of the organizational constructs, and I'm interested in your perspective on talent and some of the things that you're doing around the computer language initiative and how that's a really a new approach for growing this talent base that's needed.
This is my favorite topic to talk about. So often, we've said people a couple times, but for every organization, they pay lip service to the people topic. They say people matter, right? But then somehow down the line, you buy a lot of technology, or you buy new software, or you change your organization, but you're not tapping into the indigenous talent you might already have. It started with a meeting at the Pentagon, kind of a usual meeting that we have, that where are we going to find the people to keep up in this age of great power competition? Can we find them? Can we train them? Can we just afford to hire a bunch of contractors? And we kind of left with no real way ahead. You leave that day and you just say, well, we'll have that conversation again one of these days. Then it ended up on a late night or early morning phone call, depending on your proclivities, to Colonel Brown and I'm pretty sure Josh Marcuse. When we had to look at the way you can't hack the bureaucracy unless you understand the bureaucracy for us. And the languages of our future, the operative languages of our time, albeit they are constrained languages, but they're coding and programming. And the United States Air Force, and I'm quite certain that this figure is equal across all the services, is 88% millennial, right? Hashtag adults under 40. But, but at the same time, you will not find an 18 or 19-year-old who doesn't know some sort of computer language. Mm-hmm. And we talk about AI a lot, and we place it on this pedestal that it's something that should only be performed by those who know floating point math or researchers or something. But these languages are becoming less constrained. I promise there are 18 or 19-year-olds or 28 or 52 within your organization that do know how to do these things. We just haven't asked the question to them. So we decided that we're going to ask the question from now on. The Department of Defense has a long history of recognizing the critical and significant value of foreign language aptitude and proficiencies. Well, why don't we just do that for computer languages? This was last August when we came up with this idea. Fast forward to most recently, you'll see that reflected in a current bill for the digital engineering bill sitting on the House floor. You will also see this reflected in the National Defense Authorization Act, the draft as it stands right now. And this is a way to tap into and reward our entire workforce. And it does go for also private industry to ask the question, do you come in with these skills and how can we utilize them? If you can't do, RPA well, you're certainly not going to do AI well, if you don't know your business to that level. So I think it's important to empower and unleash your workforce. And then furthermore, what we hope this becomes is like the National Defense Education Act of 1958. When Sputnik happened, we realized we were behind. We lived in an age when people were taking home ec classes. When Sputnik launched, by the way, Leave It to Beaver was premiering. America was in a different place. And what we want to do is make that the critical recognition of our times. And just from grassroots marketing efforts as we speak right now, there are 2,900 airmen who have already identified themselves as having this skill set. And I think that could be expanded across the entirety of the federal government.
That's amazing. It's awesome to hear that you guys are doing that. I guess if I were to follow up with one question, perhaps there aren't people out there with this trade or this skill set. What would you advise them to do?
Well, the barriers to entry for education have never been lower. That's most certain. What comes with what we're working on is not only the identification that this is valuable to us and we want to empower people to solve their own problems, but furthermore, when it comes to the language model, well, then it drives a new conversation. It's how are you using these people? What are you doing with them? So what we are now talking about here is what we call digital university, and providing this contemporary education model that is always accessible, that gives them real life skills. So when they leave the Air Force or they leave the Department of Defense, people say, hey, what happens when they all leave you for a $140,000 job? Good, grand strategy. We want to be a part of this entire movement as a nation, but offering those contemporary education models and license agreements to say you always have access if you want to empower yourself. I do believe in the model of being on site. We see that work, but there are a number of incredible organizations that provide this sitting in Washington, D.C. right now.
Excellent. Yeah, there are a number of people learning right now a new trade, so in this building, and it's exciting.
If I could just build on that for 1 second.
Absolutely.
I mean, first of all, I completely agree with everything Mike said, but I think another implication of this, and I say that as being one of the people that doesn't write code that you're referring to, is that there is a historic pattern of segregating what we call sort of IT from the rest of mission. And I think Jobu made a great point about that. AI is going to transform everything that the government does. And you're going to need some people at different levels of skill who will build that machinery, who will build those tools. But you're going to need everyone else throughout the organization to also rethink what they do.
Yeah.
And so a lot of it is not necessarily just, how do you field a generation of people that have those capabilities, but it's time for everyone else to accept that their work is also going to evolve. And we, indeed we call it .MLPF. It's doctrine, organization, training. It's all the way across. So it doesn't matter whether you know how to write the tools or not. Everyone is going to have to come to grips with what this means for their business.
Absolutely.
Can I add to that as well?
Of course, Pamela.
I opened the floodgates, sorry.
No, it's okay.
To add on top of that is to complement what they have said. And then I was just thinking about how, when we are working with AI, we're getting to the place where AI is just naturally going to be embedded in business processes and the things that we do, and embedded in technologies, right? So it's going to become the norm. So today there's this big emphasis on, in some places, there's this big emphasis on what are you doing with AI, right? Tell people what you're doing. Let everybody share what we're doing when it comes to AI, right? Well, I'm ready to look at, not share what we're doing with AI, but let's look at, based on the things that we are doing, what are we going to do next, right? And how are we going to use the AI experiences that we are cultivating? And are we really cultivating these experiences? And when it comes to the people side of things, the main point that I want to make is I think that it's good that you have data science backgrounds or computer science backgrounds, but when it comes to artificial intelligence, it's also those that don't have those skills that will make the difference, because they are the actual consumers of the services that are rendered via AI. And I think that that's one thing that I'm a little bit worried about is and that's why what they're saying I totally agree with. We need the technical skills, but that's going to become the norm. AI is going to get embedded in processes and everything. But what about the fact that we want algorithms that are, as they say, unbiased, or algorithms that are developed and generated based on real life practical experiences? There comes the business analyst, and there comes just the subject matter experts in an area, right? So I think if I were providing advice to, for instance, folks in universities, I would say, be the best at whatever you can be, and when they start talking about getting involved with AI, get involved. Don't think that you're exempt because maybe you aren't specializing in data science or AI, for instance, but get involved because you are ultimately impacted.
Excellent. Anybody else? All right. Joe, back to you with a quick question for you. We've talked about people. We've also talked about some level of partnerships and the importance of partnerships in terms of this particular technology. Can you talk a little bit about how you view partnerships either with academia, industry, and maybe talk a little bit about how you've stood up a partnership with MIT?
Yeah, you bet. So, I mean, I talked about blind spots earlier. I mean, it's something about technology that, I think when we want to make advances in the degree and at the speed that we want to, it oftentimes requires us to step outside of our corporate process and our corporate culture with the right partner to move forward, right? And so we've seen that a number of times. I think many of you are probably familiar with Kessel Run and some of the efforts we did there. And so I could list many other examples. But back in February, the Vice Chief of Staff of the Air Force, General Wilson, asked me, how do we make AI real, right? How are we going to? So we have a DoD AI strategy. We have a White House executive order on AI. How are we going to make it real? So I pitched essentially going to and approaching MIT, and so I went to MIT. I worked some connections, and they were all in from the beginning. It was really great to see. It was super encouraging. And so the vice chief and I went up. I later went up with Dr. Roper. There was an MOU signed. Long and the short of it, several weeks later, and with at the time Secretary of the Air Force Heather Wilson's leadership, we were now working a contract. We got it's something called a cooperative agreement with MIT. We found 10 airmen. We have airmen, eight officers, 2 enlisted, plus an 06 test pilot, Colonel Laz Gordon, who's the director. And so we have airmen who are there currently and who are on the way. And they are going to embed in these MIT project teams. And so what we did was we went out to the MIT faculty and we asked and we said, here's what the Air Force cares about. And, what are your ideas? We got 160 responses from the entire faculty, which was amazing. But we had to whittle that down to 10. And so we spent the entire summer working through how we whittle that down to 10. So they are projects along the lines of, and these are all projects that are, and I'll kind of explain how this pipeline will work, but these are projects related to kind of tough tech challenges for the Air Force. So predicting weather in areas where we don't have any type of data is one project. How do you navigate when you have no GPS signal using the Earth's magnetic field and using AI, for that purpose? AI for personnel recovery, using swarming technology. AI to reduce the interference on communications, so you can essentially use algorithms to go from 2 bars to 4, right? AI for operational scheduling. Doesn't sound like a very challenging problem, but that's our crowd pleaser, if you will. I mean, it is one of the major pain points for airmen throughout the Air Force. AI for imagery fusion of different types of imagery, especially synthetic aperture radar imagery. AI that essentially builds an Alexa that can understand our military jargon. Right? So there are a million use cases for that. How do you run AI on legacy software systems is another, especially on things like the Air Operations Center. Rather than try to, gut all of that IT infrastructure out, how can we possibly, run AI on what we already have? And then, how do we do AI for essentially, having a co-pilot in the cockpit? We call this project R2D2, right? Another Star Wars reference. So the point is that we're not going to take a bunch of capabilities that we develop at MIT and drop it into Air Force programs. The researchers there are going to create the conditions for a challenge or a competition. So what the Air Force has done really well, I think, in the last couple of years, especially through AFWERX, is to create venues that bring solution providers and problem owners together in very unique ways, and then move across different types of procurement pipelines, sometimes small business pipelines, sometimes commercial solutions openings, to be able to get to prototypes and then, over the valley of death into an Air Force program. What we were missing, I think, is research, especially as it relates for tough tech, and bringing this research arm, creating those conditions for a challenge or competition. So, for example, that navigating without any GPS signal using the Earth's magnetic field. They're literally going to fly one of MIT's aircraft around and then build a data set and then offer that data set as part of a challenge or a competition and then have the private sector come in and then work through all of that. So it's really exciting. I think it's in a lot of ways very unique and groundbreaking, and it's going to be interesting. And it was only because of this partnership that we could start to see new ways of actually creating capability. Had we not done that, we would have tried to double down on a lot of things that some work and oftentimes they don't.
That's excellent. Congratulations. I'm going to inject real quickly here and come to you, Tom. Partnerships. What does that mean to you at the PTO?
Yeah, so a great question. We often work with professors from multiple different universities. We actually have an exchange program called the Edison Scholars, and they actually come to the PTO as it is and work with us. And in particular, we have one currently that's focused on artificial intelligence. And to do a plug, we actually have an AI expert position that's open right now. It closes November 8th for those that are interested. This is how focused we are on doubling down on these efforts. So these partnerships are a great way to get at sort of the downstream what ifs, right, to our problems. And so where we've often found that quite interesting. We also do some partnering internationally with other entities, intellectual property offices. But for the most part, public-private partnerships is actually a little bit of a challenge for us because our ability to do that is not actually part of our agency's wheelhouse. So we don't actually have the ability to do direct public-private partnerships. However, we are endeavoring, of course, in different vehicles to contract and work with IDIQs and other agencies and looking to merge and partner with other agencies that do have that authority on behalf of that. So we find it great because there's other entities that are also trying to find similar things. There's a whole universe of documents that everyone wants to be able to find at a ready notice. Obviously, for us, it's important for understanding, if you will, like a visual mapping of the universe of public content and being able to go, I've been here, I've been there, and I've covered all the areas that are necessary. So that's not unlike many other organizations that have tons of grant data or catalog data, as Pam mentioned, that they're just even keeping an inventory of what's in your attic can be a challenge, let alone what exists everywhere around the world. So that's actually one of the really interesting universal concepts of what we call search, but I kind of call it rummaging. It's really just the ability to force multiply a single person to be able to identify readily these documents. And of course, it requires a lot of natural language processing, and I know in certain intelligence work, it's very important. But it's also very difficult and challenging for us. We're one of the largest repositories of innovation and R&D data writ large. So the USPTO had granted its 10 millionth patent. And what is a challenge, though, at the time light bulb was invented, that wasn't a word. So we're constantly dealing with the evolution of terms. And that is something we're always chasing. These terms of art didn't exist at a certain period of time. And what you have to be able to do is go back in time and identify if that was the intent of a prior term and move forward and be able to realize and recognize these terms are coming into play. And they have meaning because this is how we lay out the intellectual property fence, if you will, through our process. So we're very particular about terms and language. So it's very discreet to us, but of course all of us may have a different interpretation of things. So it's something we challenged with, but I think it's common to a lot of organizations, which lends itself well to partnering.
No, I think that's great. I continue to tell my teams English is a liability that we have to be aware of. I want to pull the thread back into the talent question and come back to you, Josh. Mm-hmm. There's some things that you're working on right now, and in particular, a campaign for AI Ready Force. Right? I'd like you to talk to the group here a little bit about what that means and what does readiness mean in the context of some of the national mission initiatives.
That's great, and I love that this is emerging as a central theme of this conversation because it's just exactly where government needs to be thinking about it. We know that for the Department of Defense, readiness has been for decades one of the most important metrics of success for the organization. And we were trying to understand, how do we use all of the strength and robustness of appreciating what it means to be ready and to organize and train and equip in a force that's ready, and understand what does that mean for the digital world? What is digital readiness? And given the level of senior leader attention and focus on this question of how do we prepare for an artificially intelligent enabled future, what is AI readiness? And so the Defense Innovation Board also last Thursday decided to offer a definition. So we're saying an AI-ready force, and I think this applies to any organization, is a force that has the capability and capacity to understand, design, develop, test, evaluate, deliver, sustain, and scale AI in support of mission. If we understand that as the definition, then that allows us to walk back and understand to what degree do we need to be able to do these things as this technology advances. And also, remember, this is a competitive space, so now we need to think about our readiness in relation to adversaries or competitors who are also racing to invest and develop and field this technology, may do so differently than us. And it also allows us to figure out, how do we use things like the Computer Language Initiative or other training and education recruiting to get there. Everyone has said, we need more of this, but now we have to get serious about how much more do you really need and what does that look like? So I think the holistic view of this is really 4 pieces, and we've talked about a few of them, but it's worth throwing out a framework to discuss them all. It's people, but it's also the data they need to train the algorithms, and the ability to share that data and get access to it, making that data affordable to own and accessible to use. It's the infrastructure, because it's great to say you want to start with people, but all those people are going to leave as quickly as they come if they can't get access to an authority to operate the system that they just built, right? They need to have the right tools, techniques, platforms to actually use their gifts and skills. And it's organizational design. And that really gets to the point you were making about MIT, which is it's not just enough to have an investment in the technology if you can't get it into the hands of the people who have to give the developers the user feedback to make it relevant. So that's the definition we're advancing in a 4-part framework we hope is really going to add more layers of reality to the discussion.
Excellent. Yeah, Tom.
So I'm going to just add one punctuation point that we found in our inventorship data for patents. We learned as of 2009 that there are more patents being granted to foreign nationals than domestic. So if that doesn't tell you exactly why we have an issue domestically in terms of who is based on innovation data, we're actually lagging in this field. I mean, it's really surprised us to see that point, and that inflection point has continued to divide.
Wow.
So it's just a reality, and we need to catch up. That's the message here.
That's an excellent message.
Yes.
Yeah.
It's a bit.
I hadn't gotten that news report, so you guys are watching me let that soak in and what that means
as of
for us.
2009, and it's continuing to diverge.
Wow.
Interesting. Hey, Tom, let's keep it with you. You touched on international a couple times earlier. Can you talk about how perhaps some other countries are dealing with some of the intellectual property considerations that you touched on earlier, and maybe where we need to go in terms of our thinking and perspective?
Yeah, it's a great question, and I really appreciate the talk about workforce. And there's also really just sort of the acceptance of doing it. Yesterday I did my job this way, and tomorrow am I going to really change, especially in a knowledge worker, knowledge management context. Internationally, we certainly do feel the pressure of competition. What's interesting is some of the smaller intellectual property offices around the world have the ability to really leapfrog because they are smaller. They're dealing with smaller constraints than we are, and they're ready to adopt and jump to the next level. Some of the larger organizations, such as ours, it's a bigger ship, if you will, to move left to right. And so I can unequivocally tell you we have what is called the Intellectual Property 5, which is Korea, China, EPO, European Patent Office, and Korea. They are all very, very aggressively in this space, and aggressively meaning aggressively filing in this space. I know for a fact China they get 1 million applications a year actually, domestically. And in this, we're starting to track this technology specifically to figure out what the growth rate is and where the pattern is. And to Pam's point, it's going to ultimately be fused into diffused. I mean, I think at one time we said powered by the internet. I don't think anyone talks about that anymore. So we're going to get to this point. But in actuality, you're right, there's a divide as to those who create and those that consume. And the concern here is that while we're trying to compete to be the most attractive place to do business, we also recognize doing business in the intellectual property world is a global supply chain, right? You don't just get a patent in the United States, you get them all around the world. You have a global market that you're after. And so the challenges we're seeing is that other countries are doubling down and actually focusing, funding, setting policy, and pushing in that direction. So we certainly are in a race with this. I would call it a space race for sure.
Yeah. Excellent.
And that's how they're approaching it. The policy side is one aspect, right? That'll be litigated as to whether, I don't know if you've heard about some intellectual or AI that's been writing I don't know if it's the Lord of the Rings or some books that consumed the books and then wrote another subsequent book, and authorship and inventorship and all this kind of thing coming from a computer is one part of the piece.
Right.
The bigger puzzle is who's owning the intellectual property in that space, because that's going to be a real game changer.
I agree. Pamela, over to you. What do you envision or are you seeing right now with being some of the biggest challenges from operationalizing and deploying AI at Department of Energy?
Some of the biggest challenges are we have a highly federated environment, and we respect the federated culture, right? It is what it is for a purpose. So that's a good thing, but then there's challenges with that. We need to get to the place where the AI algorithms are governed. I think governance is one of the biggest challenges because I don't think we really understand what that means yet. And trying to communicate that when we're so excited right now about generating AI models and generating these algorithms, some of us are standing back going, okay, that is really good because we know we need this. But we also need to reuse these algorithms, we need to reuse these models, and we need to watch the internal threat, right? So are we modeling in such a way that, how are we monitoring that? Because you can do some serious stuff now when it comes to models, right? And so there's the external threat, and then there's the internal threat. And so I'm an innovator by trade, right? So I'm like looking for the challenges so we can quickly figure out what we can do to address some of these challenges before they become, real problems. And so that's why that comes to mind. But, that's one of the biggest areas. So I really love the autonomy that DOE has and the fact that we can work with the labs are working with the universities and bringing in all this knowledge and insight and depth. So I just have, it's one of the things that I just really desire, and that I'm doing everything I can to help facilitate it, is let's start operating a little bit more holistically. Let's look at getting some governance models in place that are effective. Let's try and let's experiment a little bit, because we definitely have to do that, because, it's a learning culture. And then let's do what's going to work. Let's look at how to proliferate these things across the environment itself. And then the other area is in the workforce, which we talked about earlier. I just think that from a workforce perspective, we should embrace artificial intelligence, and along with that, know that the fundamentals of data and having a good, solid data foundation, starting with use cases, not trying to do too much too soon, but starting with specific use cases to help lay out the smarter analytics platforms, things like that. I think that's the other challenge that I see, is that sometimes we get so excited until we're trying to do too much. And we need to just look at some of the fundamentals, lay some foundations, and then build on top of that so that things are a bit more sustainable. But we have a workforce that's delighted, that's very talented, and that's very good. And we certainly appreciate that. We would just like to be able to tap into those skills more across the department in addition to their specific domains.
I'll just add a couple things. So I couldn't agree more with everything Pamela said. I think everyone needs to understand bias and how that impacts AI development and algorithmic bias, inductive bias, et cetera, and where that could lead us in developing solutions. For example, HADR, right? I mean, you can bias towards specific types of data that lead you, right, to see the algorithm perform well. You're going to start collecting data in certain ways that will, the bias plays itself out, and you'll wind up, ultimately sending resources to places that may or may not need them more than other locations that, for one reason or another, didn't generate the data that you needed to, to have your model perform the way that you wanted it to, right? There's a number of different ways that this could play out. And even if you're not a coder, even if you're not someone who's technically minded, I think everyone needs to understand bias as it relates to decision making and as it relates to technology development. I think that's incredibly important. So this is something that we should educate our workforce on. There's also threats, right, as it relates to AI. And when we develop, for example, a solution that might lead us to make decisions for resource allocation in a humanitarian situation, people can take advantage of that. They can manipulate the data to either shift those resources to somewhere else or prevent those resources from going where you want them to, or you could take that data and use that in to take advantage of vulnerable populations. Right. So these are things that we need to recognize, that as we develop this technology and we get enamored by it, it also creates new challenges, new threats, new questions that we need to ask.
Excellent ad. Let me pull on that thread. I'm gonna touch on perhaps what the prior speaker talked about in terms of adversarial threats. I'm gonna pull in the threads that Pamela, you were talking about in terms of reusability, and come to you, Mike. How do from your perspective, how do we make this new technology trustworthy? What does it take an end user to see, feel, believe? With respect to the algorithms or how they're embedded into the applications that they're already using today. Can you talk a little bit about that in the final minutes?
Yeah. All right. Let's involve the audience. Who in here has used a microwave before? Just real quick. Yeah? One follow-up to that. Who in here knows how to build a microwave? Yeah, Ted, I know. Inevitably someone up there, right? Why do you trust microwaves? Seriously. Because they work, right? Because you've used them, because you've experienced them. Don't put tinfoil on that microwave. That's a bad idea, but somebody didn't know once, right? I hope it wasn't just that one time for their sake. But that's kind of where we need to get to. So what we're talking about is trustworthiness. You trust people you know. You trust people you experience with. That's the same with AI. You have to put it into the hands of them, and then we're going to go down the explainability route. Yep. That say, well, how did that work? All right, AI explainability. This might take a pop shot at somebody who's really involved in this, but let's just be pragmatic for a second. Explain to me, and think about this, how you know that's a chair. Right? What is that? How do you know that? Here's what I think you might say. You might say, well, in my case, based on my 30 years of experience, I've seen a lot of chairs. I've seen things that aren't chairs, and I've seen things, that I sit on can be used as chairs, right? If you asked an AI and you could tap in, I think it would say something like this. Well, based on the data that you fed me and these 10,000 images of chairs, I'm convinced that's a chair, right? So a lot of people are on this path where we're all the way out there. How do I explain what's happening in the most complex system in the universe? It is the most complex system, is the neural net in your brain. And they're very complex too in your machine learning algorithms as they exist right now. So what do we do about this? What I have found is successful is to, instead of run around all day long hoping you find a bunch of training quality data, hoping that somehow reflects the hacks that are happening in your workforce to begin with along that system. Bring it in, then data engineer it so it's TQD, et cetera. Start digitizing your workflows, right? Spend the time on that so that you can digitize and monitor how people are interacting, what they are doing, generating that data set. So when the day comes, and I'm talking about the proverbial chair or whatever else it is that, hey, you already have, you're doubling down on a procurement that's already occurred. There's an existing trademark on this, et cetera. And they say, well, how do I believe it? And then you walk them to the computer and say, you tagged that data. You created that. And that feels like a much more pragmatic approach, and even to the extent one could start talking about regulation. If you thought about a y-axis that says a data set's worldview, and an x-axis that says, scope of purpose, right? Small worldview probably shouldn't be an Alexa, right? Small, great worldview, why is it, a telephone switch line? Something like that. And I think that starts to generate a conversation we should have that starts to help your workforce. And at the end of the day, when you're talking something that's more akin to electricity than it is to oil, it's experiencing with it that's far more important than anything else. And I think our collective workforces, I think people are, the fear that we have as a nation, we need to experience with it more, learn what's good, learn what's bad, as opposed to just jumping I'm going to explain what, is happening inside of a neural network, as opposed to practicing with it.
Yeah.
Excellent. In the last 30 seconds, I'd like to run down the row real quickly and ask you to give one word kind of responses here. What excites you about this technology and the application of it in the domain you're working? Start with you, Josh, since you're closest to me.
Yeah, lucky me. The dynamism of it.
Okay. Pamela?
Innovation.
Innovation.
Speed.
Speed. Tom?
Possibilities.
Possibilities. Mike?
Becoming more human through AI.
That's more than one word, but yeah. Thank you for that. No, folks, I appreciate your time today, and thank you to the panelists for participating with this conversation and this discussion and advancing this technology in your own ways in your organizations. I think it's great, and thank you again, and hope you guys enjoy the rest of the conference.
Thank you.
Thanks for having us.
Absolutely.